Would you like to be able to spend more money? How much money can you spend? Here's a thought experiment for you. What if you were able to spend the exact same amount of money every day of your life? How much money would that be? Young or old, past, present, and future, the exact same amount every day. In order to answer this question, I am making a spending simulation game. This is the dashboard of the spending game. I'm going to explain, filling in the other boxes. Disclaimer: this is in no way financial advice. In fact, I'm trying quite hard not to give any advice. This is a game made for fun and not to be taken seriously. Go do your own research and hire a real financial expert if you are looking for advice. To know how much we can spend, we first need to know how much we will earn. And we will need to know how much we have. In the previous video, we talked about ways to estimate a person's salary and earnings over their career. This video is about the more fun side of that coin, how much you can spend. A person's income often changes a lot over their life. The stacks represent their earnings. When a person is young, they may not earn so much, so the stacks might be fairly small. Earnings typically rise and then peak in a person's 40s or 50s, so the stacks here are shown taller. After a person stops working, maybe in their 60s or 70s, they are no longer earning a salary, and so the income stacks are shorter. So how do we even out the stacks so we can spend the same amount every year? We can think about it like a river flowing into a reservoir. The flow of water coming in can be thought of like earnings, and the reservoir itself can be thought about as savings. And the amount of water flowing out of the reservoir is like spending. And so how do we get a consistent flow of water out of the reservoir all the time? I'm not the first person to think about this problem. Thomas Stanley, the author of The Millionaire Next Door, has a calculator in his book. He says that you should take your age multiplied by your income and divide by 10. And this is supposed to be your expected net worth. People who are under accumulators of wealth are those whose real net worth is less than 1/2 of this expected value from the calculation. And people who are prodigious accumulators of wealth are people that have more than twice the expected level of net worth according to the calculation. This formula is very rough, and it fails to take account any changes over time, like if someone earns much more or much less than they did before. The actual savings would not be equal to their expected net worth. I want to look at a more dynamic way to do this, which takes into account more factors. Let's take a look at a 35-year-old example person who's earning a take-home pay of $100,000 after taxes. $100,000 earnings after taxes means about $150,000 before taxes. And so if we multiply $150,000 times their age of 35 and then divide by 10, we get an expected net worth of $525,000. But let's say this person is an under-accumulator and they've only saved up about $100,000. But also let's assume that they expect an average raise of about $3,000 per year, which is about 3%. Let's say that they also want to be able to leave a bequest of about $100,000 to their heirs. And just to make the math easy, we'll take all these numbers to be after taxes, so we do not need to consider taxes. And also we'll take all the numbers in today's dollars, so we do not need to consider any inflation. The simulation first calculates their expected lifespan and the probability of disability. The simulation will calculate hundreds of possible lifetimes for them. And the more we push the runs button, the more possible lifetimes it will calculate. Then when we press the simulate button, their salary and spending are calculated. The salary in the dotted lines is expected to increase at the 3% rate, but that's only an average. The simulation takes a distribution, so their raises could be better or worse than the 3%. And here's where it gets interesting. For this hypothetical person, with each hypothetical situation, the simulation calculates how much they can spend in each year given those assumptions. If they're lucky and their salary goes up or their investments go up, they can spend more. And if they are unlucky, then they will have to spend less. If we look at the 50th percentile for this hypothetical person, their income rises from today's $100,000 to a future of $175,000, assuming they get many raises over the years. Their net worth rises from $100,000 to about $1.8 million when they retire due to their savings. And if we divide their wealth by the number of years that they have remaining, we arrive at an amount of spending per year that should be constant. This is also about $100,000. It happens to work out this way such that any raises they get above the $100,000 they cannot spend, and they need to save all their future raises to be able to fund their retirement. So now that we have the framework, we can use this simulation to look at other example people of different ages and in different situations.